Welcome back, everybody. Today we're going to continue with our study of trigonometry. Okay, in 8.4, angles of elevation and depression, basically what we're going to do is we're going to take the trig we taught you in the last lesson and apply it to some real-world situations, apply it to some story problems in this lesson here. Okay, objective to use angles of elevation and depression in problems. Okay, we'll explain what those are in a second here, and like we said, keep building with this trigonometry. Now, as far as a definition for angles of elevation and depression goes, I think it's probably easiest to think about with a picture here. So you can fill that space in the note guide with just what I have here. And basically when I say angle of elevation, we're talking about the angle formed when we're looking up at something, the angle formed between the horizontal line of sight of the person and the line of sight up to whatever we're looking at. So angles of elevation are looking up. And then an angle of depression is similar. It's going to be the angle formed by the horizontal line of sight and the line of sight down to whatever we're looking at here. Okay, so angles of depression are looking down. Now, there's one key relationship between angles of elevation and depression. I know they're always going to be congruent to each other. So as in, if I know the angle of elevation, I also know the angle of depression, and vice versa. And the reason for that is we'll say both of these horizontal lines are parallel with the ground, meaning that they're both also parallel with each other. So what I have then are parallel lines with a transversal. If we think back to chapter 3, the angle of depression and elevation are alternate interior angles. We know when those lines are parallel, those angles will be congruent to each other. Okay, so that's how I know that if I know one, I always will know the other one. All right, so first thing we're going to do today is practice just using those definitions. So problem 1 says, what is the description of each angle as related to the situation shown? So in other words, we have a situation, we have some context here, and we want to describe each of these angles, 1, 2, 3, and 4. Okay, starting with angle 1, I'm going to say that is an angle of depression. Okay, because it is between a horizontal line and a line below that horizontal line. So this is the bird or whatever the heck this is looking down. Okay, so we'll say depression, and then we also want to describe it. I'm going to say it's depression from the bird to the balloon. Okay, we can do the same thing with angle 2. Okay, now angle 2 I'm going to say is an angle of elevation because it's between a horizontal line and a line above it. So here we're looking up. And we can say elevation from balloon to bird. Okay, so there's an example of each kind of within some context, and you want to describe where it's coming from and where it's going to. Now we can quickly do the same thing with angle 3. Okay, angle 3 is below the line, so we'll say that's depression. And we can say from balloon to, we can say right here is the mountain base. And the same idea with angle 4. Angle 4 is going up, so we'll say it's elevation. And I'm going to say from mountain base to balloon. Okay, so again, here we're just practicing using that vocabulary. An important question, just because we get into some real world situations in the next two questions, when we say angle of elevation, when we say angle of depression, we want to understand how it relates, okay, to that scenario. All right, so for the next two questions here, we're going to do one angle of elevation question and show you the different tricks and kind of how those problems work, along with one angle of depression question. So let's do the angle of elevation first. So problem 2 says you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground and you're 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? Okay, so we've got a real world scenario here. Now this question didn't come with a picture, so I'd say for sure draw one. Now we've done some stuff in the past where you could probably skip the drawing phase, but for a trig question like this, you definitely want to have that triangle in front of you so you can identify which sides of the triangle you're dealing with, okay, which trig ratio you have, how that trig ratio is going to be set up. So don't skip drawing the triangle for this one. All right, so we've got a cliff. Here's you down below. And let's say we see a rock climber on it. Okay, so you sight the rock climber at a 32-degree angle of elevation, meaning that the angle between my horizontal line of sight and line of sight up to the rock climber would be 32 degrees. Okay, an angle of elevation, so looking up. Now, how would you measure that angle? There's some pretty simple tools you can use. Okay, in class, we'll actually practice using those after this lesson. Okay, it says that your eye level is 6 feet above the ground. So we'll put that right here. All right, and you're 1,000 feet from the base of the cliff. Remember, we see base, we're talking about along the ground. So that'd be 1,000 feet right here. And we want to know what's the height of the rock climber. So we'll call this height here, we'll call that our x. Okay, so I've got things sketched out, and what I'm looking for here is to figure out what's going on as far as right triangles go. So I've got my right angle here, my 32 degrees in this lower left corner, meaning that I'm looking for the opposite side to that 32, and I have the adjacent side. Okay, opposite adjacent, that's my tangent ratio. So I can set this up as tan of 32 degrees is equal to the opposite x over the adjacent 1,000. Okay, so there's my trig ratio. Then we'll solve that for the x. To do that, I'm going to multiply both sides of this equation by 1,000, which leaves me with the x by itself already. So x is just equal to 1,000 times tan 32. And when we get the x by itself, we'll go to the calculator, and we'll plug this in the way we see it. 1,000 times tan 32. And when I do that, I end up with a 624.9 feet, we'll say. All right, so we've got x equals 624.9. Now, I'm not done with this question yet, and here's the trick anytime you're doing a real-world problem using an angle of elevation. I need to account for this 6 feet here, because when I figured out that x, I figured out the height of x 6 feet off the ground. So to get the actual height, then what I'll do is I'll take the 624.9 I just found, and I'll add to that the 6 feet. Okay, for a total of 630.9 feet. All right, so anytime you're doing a angle of elevation question, look in the problem for where you're measuring from. Okay, in this case, it was 6 feet above the ground, because real world, you're very rarely, or I'm not sure of a situation where you actually put that measuring device on the ground. It's always going to be up off the ground on some type of transit or in your hands or something like that. All right, next up, let's take a look at how to do an angle of depression problem. So this one says, to approach a runway, the pilot must begin a 3-degree descent starting from the height of 2,700 feet above the runway. To the nearest foot, how far from the runway is the airplane at the start of the approach? Okay, so let's draw this out. We've got a airplane. We'll say that's what an airplane looks like. And a runway we're trying to land at. And it says the pilot must begin a 3-degree descent. Okay, so in other words, have a 3-degree angle of depression, meaning that the angle between the pilot's horizontal line of sight and line of sight to the runway is going to be 3 degrees. And we're starting from a height of 2,700 feet. So we'll put that right there. Now, a common mistake I see on angle of depression problems is students want to put the angle of depression right here. Okay, nope. Angle of depression we defined as an angle between a horizontal line of sight and the line of sight looking down, not the line of sight down to the perpendicular. Okay, we could find this angle if we wanted to by subtracting from 90, but that's not where the angle of depression is. Okay, and here we want to know to the nearest foot, how far away from the runway is the airplane at the start of the approach. Okay, this is something that back in the day pilots had to figure out manually. Okay, now our navigation systems are figuring it out for us though. Okay, if we want to have a nice mild angle of descent, how far away do we need to be so we hit that runway that's, okay, still possibly a state or so away. Okay, so I've got my right triangle here. And trick with this one, remember we said that the angle of depression is always going to be congruent to the angle of elevation. So I know I have a 3 degrees here as far as my situation goes. And then for this one, how far from the runway is the airplane at the start of approach? In other words, what's the distance between the plane and the runway? So for this one, I want to solve for the hypotenuse of the right triangle. Now, with a question like this, unless it explicitly says what's the distance from below the plane along the ground to the runway, we're always going to be thinking about that direct distance. Okay, this would be the distance that a radar or a rangefinder gave us, that distance directly between the two. Okay, so let's see what we have here. This time we know the opposite side from the angle, the 3 degrees. We want to find the hypotenuse. Okay, opposite hypotenuse, that's my sine ratio. So I can set this up as sine of 3 degrees is equal to the opposite, 2,700, over the hypotenuse, the x. And then we've got to solve this guy for the x. I want to clear my fraction first, so I'm going to multiply both sides by the x. It's going to get rid of my division on the left, leaving me with a x times sine of 3 degrees is equal to 2,700. And then you get the x by itself. I'm going to divide both sides by sine 3 degrees. Whoops, not 30, but 3 degrees. That looks a little better. That's going to cancel out the signs on the left, leaving me with just x is equal to 2,700 over the sine of 3 degrees. We've got the x by itself, so we'll go to the calculator. That's not what I wanted. Oops, there we go. All right, so 2,700 divided by sine 3. And I'm ending up with a 51,589.7. Okay, that's a lot of feet. I'm just going to round that to the nearest foot. We'll say 51,590. All right, if you've ever been on a plane before where they start the final approach, you know that you actually start going into land. Okay, probably half an hour away, so makes sense that our number's so huge here. That's it for 8.4, our lesson on angles of elevation and depression. Basically, we're just doing the same trigonometry we've been doing for a week or so now. Okay, difference is there's a few kind of special tricks that we showed you for dealing with angles of elevation and angles of depression. Okay, so that's it. Have at it. Start getting the practice done and let us know if you get stuck. We'll be here to help you out.